For example 2, we want to be able to use the quotient rule for logarithms. So let's go over the definition for the quotient rule for logarithms. The quotient rule for logarithms can be used to simplify a logarithm or a quotient by rewriting it as the difference of individual logarithms. The log of base b of m divided by n is equal to the log of base b of m minus the log of base b of n. So we're subtracting the log of what's in the denominator. Now in example 2, we're going to use the quotient rule for logarithms to expand the following question. How do we go about that? Well, given the logarithm of a quotient, we're going to use the quotient rule of logarithms to write an equivalent difference of logarithms. Number 1, we're going to express the argument in lowest terms by factoring the numerator and denominator and canceling common terms. Number 2, we're going to write the equivalent expression of subtracting the logarithm of the denominator from the logarithm of the numerator. And number 3, we're going to check to see that each term is fully expanded. If not, we're going to apply the product rule for logarithms to expand completely. So for this example, we want to be able to expand the log of base 2, and what we have on our numerator is 15 times x times the quantity x minus 1, divided by the quantity of 3x plus 4 times the quantity 2 minus x. So we first note that the quotient is factored in lowest terms. So then we're going to apply the quotient rule. Well, again, the quotient rule tells us that we're going to be subtracting the numerator, so the log of base 2 of the numerator, which is 15x times x minus 1. And since it's division, we're going to be subtracting here. And then the denominator is going to be the quantity 3x plus 4 times the quantity 2 minus x. So now we have that logarithm. So minus the log of base 2 of the quantity 3x plus 2 times 2 minus x. Okay, now notice that the resulting terms of logarithms products. So these are products. So to expand completely, we apply the product rule, noting that the prime factors of the factor of 15 are 3 and 5. So here we have the log of base 2, and we're going to just factor 15 to be 3 times 5 times x minus 1. And then minus, if you notice, I'm putting parentheses around this because I'm going to be subtracting. And this is the log of base 2 of 3x plus 2 times 2 minus x. So here I'm still keeping the minus sign. I still have my parentheses. So when we expand inside the parentheses, that multiplication becomes an addition of logarithms. So now we have the log of base 2 times 3x plus 2 plus the log of base 2 of 2 minus x. The next step is to distribute the sign. So our final result is going to be the log of base 2 of 3 plus the log of base 2 of 5 plus the log of base 2x plus the log of base 2 times x minus 1 minus the log of base 2 of 3x plus 2 minus the log of base 2 times 2 minus x.